Hey guys, and welcome back to class as always. So today we're going to go over a few lessons that I know some of you have missed because you've been out and you've been away for a while, but that's okay because we have our beautiful friend called Mr. PowerPoint. So let me move this down here and figure out which one it is. It's this one here. I have a lot of PowerPoints open because there's a lot of things that I need you guys to learn today. And I'm going to read to you what some of these stars say. So we did this little blue piece of paper that you guys should have gotten when you were on Teams. And it is called The Characteristics of Stars that I put inside star magnitude. There it is. So this is what it is. This is one of the ones we worked with. That one there. And then we had another one that we worked on later on this week. And where did it go? So there's one that we worked with our, here it is. So this one here is what we worked on. For the kids who were in class, it's blue. For you guys online, it's white. And I know you guys were having issues with seeing some of these stars. So when I pull up my PowerPoint, it's like you can't read some of these stars. So I will be more than happy to sit down with you guys and read them with you. In fact, I'm going to fill this out, help you fill this out. So I've enabled the content so that I can sit here. It says list 4 ways that you think the stars can be grouped. So I'm going to say color. Yeah, let's make this. Let's change this. All right, let's change this up because you know I like things to be changed. I'm going to change my words here to red. I'm going to say color. I'm going to say brightness. What else can there be? How about size? What about temp? Let's go back some. Yeah, temp, not capital T. Temp. So I'm going to figure out what's wrong with this thing, and we're going to just move on from here. Okay, so there's 4, and it says sort the cards by the pattern, so they're already sorted for you, but they're really hard to see, right? Right, I mean they really are. So it says what colors have the most, which ones have which stars. So the large stars here, right? Those are the large stars. And it says, what colors have the largest stars? And the largest stars come in the following colors. So I'm going to change my colors as I type along. So I'm going to say yellow. My color didn't change. So we're going to try that one more time. We're going to say yellow. And we are going to say red, and then we're going to say orange. Okay, and what's the smallest stars there? The smallest stars are white. Okay, so the smallest stars, the little tiny stars, let me pull this back up for you really quick. These are little tiny stars, and they are white. So I need you guys to know something. If it's larger than 1, it's bigger than the sun. If it's larger than 1, it's bigger than the sun. It's brighter than the sun. So it has this 1. This has 0.1. So it's brighter than the sun. These are all brighter than the sun. And we're going to go over the map on that in just a second of how this jumps up. So let's look at the next one. So the next one says, sort the cards by color and look for patterns. Is there a pattern between color and temperature? So is there a pattern between color and temperature on this, do you think? So I'm going to let you have a second to sit there and figure that out. I have an actual bag of these stars with me so that I can pull out those little tiny stars because I know how you guys feel. I can't read that. That's too small of a thing to read. I'm sorry if you hear my crinkly bag. That's too small of a star to read on there without that. So if I were to sort these out and I were to look at them with you guys, what kind of patterns do you see? All right, what that means is it says color and temperature. They're what? Color and temperature are normally related. So related. So color and temperature are normally related. They're related. They're sort of the same. There's something that sits there, and they do the same things. So it says color and temperature. So is there patterns? So yes. So I want to see nice, good 8th grade writing here. I want to see you guys go like this. Yes, because they are related. All right, and the next one, which colors have the highest temperature? Which color has the lowest temperature? And it says, list the colors starting with the lowest temperature. And I want you guys to see this word here because you guys were seeming to misunderstand that. Lowest temperatures, okay? And end with the highest temperatures. So ending with I don't know why this is not wanting to go. I'm having technical difficulty still. That's great. Ending with highest temperatures. All right. So start with the low temperatures, end on the high temperatures. Start with low, end with high, and you put that there. So I'm going to jump down to this table because you guys were doing really awesome with that table on your own in class. However, I'm not sure how the boys and girls at home were doing. So if you guys need help with this, so this is size, color, temperature, and luminosity, which is brightness. Okay, so I'm asking, what's the size of the sun? So if you're looking at this PowerPoint, the sun is right here. So these are small stars, these are medium stars, and these 5 right here are large. So all you have to do is write large, medium, or small. And then you're going to say sun. Really easy. What color was the sun? I do believe. Or it was orange. One of the two. It was yellow or it was orange. He was yellow. There he is. So he's yellow. And what else does it ask about our sun? Because I'll fill in just the first one. So it asks about the temperature. Let me find my sun and thing so I don't have to keep flipping back and forth. Alrighty. Because that PowerPoint, I might just make a new one for you guys at home who need this. So our sun's temperature is that one temperature that says 6,500 degrees Celsius. That's Celsius, all right? That's not anything else, it's not anything special. So I'm going to go in here and I'm going to go to this insert and I want a symbol and I want the degrees symbol. Let's click more symbols. See where he's at. So inside, I love this little special characters thing because it tells you all the things you need. And I'm looking for, see this is Fahrenheit, I'm looking for Celsius. And I'm going to insert it. Did we insert it? There it is. So again, you go into insert, you go into symbols, the caret, the pull down caret, and he's the very first one right there because I used him first. So that's him right there. So he says degrees Celsius. And like I've told you guys before, when you start working in science and in space and all the other good stuff, you will not be using Fahrenheit. It's a big no-no. Because it's considered lazy. You use Kelvin and you use Celsius because working with Celsius is just the right thing to do. It's easier to do, it's easier to work with. You get a more accurate read in Celsius than you do Fahrenheit. I know you guys were like confused because here in the States, that's what we use, but everywhere else uses Celsius. So we're using Celsius, kids. Now, the brightness of the star is just a level 1. So again, think about it in the terms of gaming. Our star is a level 1 star, and the North Star is level 2000 star, so that's just how bright he happens to be. So this means our sun is brighter than the North Star. And we'll explain that on the next paper that I already have pulled up. It says how many, okay, so now based on the chart above, how are the sun and Polaris the same? So how are they the same, but what does that mean? What do they have in common? So how does the sun and the North Star, I'm going to put / North Star, so that way you guys don't think I'm crazy. So this is the North Star, okay? So this is the star that most people see in the sky, and they're like, oh, it's amazing. Yeah, twinkle, twinkle, little stars based off this one right here. He, however, is not our closest star. Okay, I want you guys to know that Alpha Centauri is our closest star, not Polaris. He is a long, long ways away from us, and we'll get into that on our next page in a second. So what do they have in common? Well, they have temperature in common. Well, they have not size, but they have color and temperature in common. They do not have brightness in common, because our sun is brighter for a reason. So since the sun and Polaris are so close in temperature, why is Polaris so much bigger, or so much brighter than our sun? Why does he appear so much brighter? Because he appears closer in space. So you guys should already answer that. You guys should know what that is. And then all you're doing to answer the rest of these questions, and what it says here, you guys are getting confused on this, and I don't understand. This is based on the above, which is this stuff right here, which is all this stuff right here, based on this stuff. What two characteristics of stars affect luminosity for the star? What two characteristics? Is it size? Maybe. Is it color? Maybe. Is it temperature? Maybe. What affects its brightness? Okay, so that is for that table. I've already filled in those questions for you, so I figured to do these questions because those are super easy. Those are super simple because that goes along with our little PowerPoint that we have gone over here in class. I know you guys are so tired of seeing this, but like I said, I was really proud of a bunch of you guys when you figured out really quick that this is Orion's belt. So that means you guys actually do look up at the stars and you do notice them, and that just makes me super, super proud as a science teacher, and I absolutely adore you guys for it. Yes, this is Orion's belt. This is what you see, and you guys are like, Orion's belt, we know that, we see it's on your wall. And then what do you notice? You notice the different colors, and I was just so proud of you guys. You guys did awesome. So what are stars? So what are stars? So let's click it. There's a, that said it was a hyperlink, I guess. What does that say? Click. Oh, well, there is a link. I guess in class we're just gonna have to go back to this YouTube channel. Oh, all right, well, I guess we, because we went through everything super fast, so I guess you guys get to see, because there's a hyperlink, because you guys already have this PowerPoint, so you can just jump onto that YouTube channel and watch, because there he is. There's our favorite little dude telling us about exactly what stars are. So what are they? What are stars? Stars are the characteristics of a star and everything else. So this is what we were doing in class. So here's the notes that you'll need to take. So go ahead, pause right now, take what you need to take down from this. I want you guys to look at this because there's some things that you're going to need to know for your upcoming exams. All right, so stars are big balls of gas that give off their own light and energy from fusing. This word here you guys are getting stuck on too. It's fusing hydrogen into helium. Okay, I want you to that last sentence right there. The last part of that sentence is fusing hydrogen into helium. So it is a process molecule where they're bonded together and they produce light and energy at the same time. That's why we don't put these two gases in the same tank. It will be very, very bad. All right, so here are the four. Hey, look, we guessed correctly. Size, color, and temperature. Color and temperature are related. Cooler stars are red. I know, this is the thing that you guys have been so stuck on. Some of you guys are confused about how things that are blue are hot and how things that are red are cooler. So when we think about fire, we think the hottest flames are blue flames. And red flames, they still can't touch a flame. Please don't do that. Absolutely do not do that. But blue flames tend to be the hottest flames, blue-white colored flames. They're severely hot. Their temperatures are astronomically high, and it will like melt your skin off so quick. Yellow is sort of a moderate. That's a good like campfire, like a yellow-orange is a good campfire. Blue-white is like a 5-10 alarm fire, like, oh my goodness, you better be calling the fire department because we don't know what's going on. I don't know why you would be seeing this color if it's not near something that is called a accelerant. So if you guys are messing around with accelerants, please don't do that. Don't be starting no fire. This is not cool or safe. These are colors right here, and when it comes to fire, that you don't want to see. The reds and the yellows, yes. The whites and blues, something has gone very wrong. All right. The brightness of stars depends on the size and the temperature. Brighter stars tend to be hotter, or, see this right here? Let's see. Let me get this little mark them up tool, because I'm going to circle this somehow. Here we go. I'm going to draw on here. Make it pink. I'm going to circle this word or. Okay, I'm going to circle this word or. Okay? It does not say brighter stars tend to be hotter and bigger. No, 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 no. Sometimes a bright star can be a dwarf star, and it can be one of the smallest stars in our galaxy. Or not our galaxy. Yeah, in our galaxy, to other galaxies around us. It can be little tiny stars, but they can be blazing little balls of hotness because they're brand new and they're still developing, and you don't want to get near those. Dim stars tend to be cooler or smaller. So we can have a big old red star hanging out, and he's just kind of turning red. He's going from that phase of orange to red to where he's about ready just to twinkle, twinkle, little kapoof. So it's like I told you guys before, the twinkle, twinkle, little star. That whole thing is about the stars twinkling. And remember I told you, when you start to see stars twinkle, and they'll do that for what seems like forever, and you guys think it's like, oh, it's so pretty, the stars twinkle at night. That's stars dying. That's them losing their energy. They start to go black, and they start doing supernova. But we'll learn about that later on next week, and I was so excited. I can't wait to teach you guys about the cores of suns. Yes, suns have cores. They really do. You guys argued with me about this right here, but I want you to pay attention to this word here, or. All right? I didn't say and. My fellow teacher buddy did not say and here. We said or for reasons. All right? So this again, which one's the hotter star? However, which one's the brighter star? He might be hotter, but he's brighter, okay? I know I'm going to say his name wrong. Go ahead, go for it. If you are not one of my students, y'all already should know I have a speech impediment, and I do believe you say Algol. Algol? Algol. Yeah, we'll say that. Anyways, Algol versus Sol, the sun. So he's level 100, so he's hot, which means this blue star is a baby star, all right? He's just a toddler just walking around doing his thing. Our sun, though, has been here for a minute. That's why he's yellow. So he's still pretty hot, and he's very bright, because you'll find out. But why does it appear much brighter? Because he's on that scale. And there's a scale that we're going to go over that you guys don't have to memorize, but I do need you to know the difference between. Okay, brightness of stars, absolute magnitude. Again, you guys were getting stuck on absolute magnitude. And I do not know why. I'm not very good at this marker thingy. I don't think you guys actually read any of this. I'm just going to I want you to highlight this whole page. I will send this to whoever needs this. Just clearly not with my highlighter. Take this out and I want you to write this over and over again if you need to. Absolute magnitude versus apparent magnitude. So there is a difference between the two. Absolute magnitude, the actual brightness of a star that depends on the size and temperature. Apparent magnitude, the brightness of a star that depends on how far away it is. All right, guys? So the actual brightness of the star depends on its size and temperature. The brightness of a star depends on how far away it is from Earth. So there could be this really amazing, cool, big, bright star that looks absolutely great. However, he can be like 10,000 light years away from Earth, and we're like, it's a dot. For us, it would look like a pinprick in a black piece of paper. So we won't be able to see it, but he might be shining and beautiful and fabulous. All right, so remember what I told you before, space versus Earth. Space, we know these numbers here, right here, all of these numbers. You're like, oh, yes, I know those numbers. Those are positive numbers. And positive means to go up and to be higher. I love working with this. I've gotten better. my fancy handwriting. And this means negative, and negative means to go down. And this means lower numbers. Right? We're so excited because we know what this means. However, in space, if you're seeing from here to here, that brightness level goes up. So everything we've learned about math is confusing now because a bunch of you are like, eh? I don't, words are hard now, Miss Henderson. Great, thanks. That's awesome. So now we're going to change this around for you. And we're going to reverse everything that you've learned in math about integers and negative and positive numbers. Because the negative numbers, the higher the negative number, the higher the brightness of the star. So I want you just to remember that. So, let's see. The higher I'm writing so well. I am doing this so awesome. I'm so proud of myself right now. The higher the neg number, the higher the negative number, the brighter the star. Just in case you were writing an actual pen and you're writing faster than me, go right ahead. The higher the star. All right, so the brighter the star. So the higher the negative number, the brighter the star. I did beautiful. You guys should be proud of me at this point because you guys were laughing at me last time I tried writing on this thing. Okay, so the higher the negative number, so say if we have like negative 100, that's a bright star. That's how bright it is. The higher the positive number, say we have a positive 100, the star is like almost black. Okay, it's going to be a very dim star. Okay, so I want you to write this down. The higher the negative number, the brighter the star. Okay, so our next slide is our very last slide here that we have in this one. And I have already shared this one to every single one of my kids on team, so you all should have this. Make this your friends. If you want to print this out, if you want to put this anywhere you want to, just so you can look at it and have it to reference for our exams, that is perfectly okie dokies with me because, you know, I never get mad at you guys for doing something. So I asked a question for those of you who were actually in class and you weren't with me. What happens if this guy here is our sun? What would happen to planet Earth? What would happen to planet Earth if this guy was our sun, or this guy, or this guy? Whoops, I did not mean to mark him out. I completely canceled his life. Sorry there, buddy. We don't want to cancel you. I want to bring you back. We'll bring you back to life, little old dude. Ha. Okay, now what happens? See, these are just regular basic stars. Woo. Regular basic stars. Now, my question is, what happens if, like, this guy was our sun? Or this guy? One of these? Or one of those? What happens here? Once again, I had asked you guys some questions, and I know there's some, like, movies that you probably shouldn't be allowed to watch, but I watched them when I was a kid. There's a movie with the actor Vin Diesel. It's called Pitch Black, and he has that thingamajigger over his eyeballs because he's currently on a planet that has how many suns? Yeah, it's like 2 or 3 suns, and it's like blazing hot, and you can't honestly see, and actually there would be no human life. It would be nothing but desert. So the depiction of that entire planet is completely wrong because if you have a super giant planet and a super giant a red star and a white dwarf planet, there would be no life, no physical possible life living. But hey, some of you have already asked me what would happen if we did have a planet that had 2 suns. What happens? Is there a solar system that has 2 suns? Yes. So, of course, we have already outstretched and we have already seen all of that information out there. And yes, there are multiple galaxies that have more than 1 star. Some galaxies have 2, some have 3. It just depends. But we don't live in that type of solar system. So it says go to the next slide. Here's this slide. I don't know what is this slide for. The data table use the star model on the next slide to complete. Okay, so this is the star. So this is the star, you guys. Hey, go back up there. This is the star you guys couldn't see, but she has it written right here. And for some reason, y'all weren't able to read that. I don't know why. Click on the link in the chat below. I don't see a link in the chat below. All right, cool. Anyway, so we are done with that assignment for right now, and we're going to jump onto this one, and then you're going to be done with the 2 assignments that I needed you to do for me. Ooh, this is new. I think I already did. I didn't do this with you guys. No, I did. I filled it out for you. That's what I did. Yep. Okay, guys. So this one was really, really easy. So this one was brightness at a glance. So what we're going to do is we're going to look together. So once again, we see here that I'm going to get out my pink marker here. Very bright stars tend to be negative numbers. So higher the negative number, brighter the star. Very dim. Higher the positive number, the dimmer the star is. It's ready for death. All right? I know it seems a little sad, but whatever. So it says on this page here, why? Oh, I'm still in my little draw tool. I was wondering what I was doing, putting polka dots everywhere. But that's okay. We'll put polka dots everywhere because polka dots are awesome. Okay, so it says we're going to use it from the first page to this page up here to help underline, figure out the stars, the closeness of it. The closest star blank is blank. So what you do is you come up here, and like I said, I'm going to always help you with the first one. So I'm going to go up here to my little insert tool. I'm going to highlight, and what you're going to do is you're going to look distance from Earth. So which one's closest to us? So I see an 8.6. Okay, that seems pretty close. So I'm just going to put, maybe I will use my draw tool. I'll use my pen. I will use in pink. Okay, so I'm going to put a little check mark for anything that's low. So that one's low. 74, no grow. 4.3, yes, we'll put a big check here. No, that's kind of high. That's kind of high. 900 light years away is not close at all, y'all. So if I see this one as our closest star to us, I'm going to be very sad. 11 light years away, that's pretty close. So I'm going to put a big check mark. 75, no. 600, no. 300, 17, I'm going to say no. 270, again, no. Anything over this. So let's go back up. The closest one I see is this one. So now it's ranking number 3. Excuse me. Ranking number 3, coming in hot at number 3 is Mr. Alpha Centauri right here. Okay, this is everything you need to know about Alpha Centauri. There we go. All right, so I've highlighted him for you, so you can put his name in here, and you are going to be good to go. So you would say Alpha Centauri is, so Alpha Centauri is 4.3 light years away, and he has an apparent magnitude which is negative. Let's double check that. Yes, it is. His apparent magnitude is negative, so we are good to go. Its brightness is, as we've seen, that is negative 0.27. So our question is why do you think that its apparent magnitude is much brighter than its absolute magnitude? So you're going to write something simple like this right here, if you're paying attention, and I don't need to tell you. I'm not telling you because I don't think you're looking. Okay, so what star is absolute brightest? Which one's the brightest star? So we're going to find the brightest star. So here's the brightness. And once again, I'm going to go back in here to my draw tool. I'm going to choose my pink pen again. And I'm going to go down the list. So which one's brighter? Now remember, the higher the negative number, the brighter the star. So this is a positive. That's a no-go. Well, that's a negative. Okay. Give that a check mark. Give that a check mark. Give this one a check mark. This one. Ooh, that looks like a good hit runner. This one, this one, this one, or this one. All right, so we have Canopus. No, it's too low on the Richter scale for me. Regal, yeah, negative 8.1. He seems kind of a good. Archer, he seems pretty okay. Betelgeuse, he's pretty high up there at 7.2. Hadard is kind of low on the scale as well, coming in at negative 4.3. And then you have the last two, which is negative 0.2 and negative 4.5. And the last one is Deneb at negative 7.2. So I'm going to say it's this one, because this one here has that negative 8. And that's the highest number I've seen so far on here in the negative section. So you're going to put in his name right there. And it says, what's his apparent magnitude? His apparent magnitude is this here. And I think that was a typo on this end. I think it must be something else, but I'm going to keep to myself about that. So we're just going to move on. You should put the apparent magnitude, and I will grade it as it goes, okay? Number 5, why do you think it appears dimmer than it truly is? Why do you think this here appears dimmer? Well, let's look at some distance. I know it says distance from Earth. Well, let's just look at distance. All right, we're going to go back to this draw tool. I'm going to get out my marker. So distance and light years. I'm not looking from Earth. I really don't care, okay? Because some of you guys argued with me. So if we look at him, how far away is he? 900 light years away. All right, because he's 900 light years away. That's why he looks dim. That's what I was talking about earlier, is you can have this big, fabulous, beautiful, bright, shining star that if he's like tens of thousands of miles, light years away from us, he's going to look like a pinprick and a piece of black paper. So it says, again, you guys are getting confused on this thing. It's the wording. You guys need to really pay attention. It says, how long will it take for the star above? What's this word here you guys got stuck on? Above. You guys got stuck on the word above. And I do not know why. It says, so if you're talking about this star here, then you're going to clearly be talking about this same star. You're not talking about anything else. You're talking about this star right here. So again, I'm sorry for the confusion if you guys kind of got lost on some things. I don't want to do that. I'm going to go back to normal. All right. So why do you think? How long will it take to reach us? Again, it's truly dimmer because it's 900 light years away. You're going to repeat the same answer here. What is the farthest star blank is light years away. So we're going to go back up here and look which one's the farthest star. So again, we're looking at distance, we're looking at light years, and we're going to go down this line. Let me go back into my draw tool. Let me get out my pencil. Okay, so how far away is it? This is only 8 years away? No. 74 years away, that looks pretty good. 34 years away, 25 years, so it's still kind of low. 900 years is a pretty good long time. So 600 years is pretty good. 300 looks pretty nice. 270, 400. How about this one down here, right here? I'm going to circle this one like this many times because I want y'all to see it. There we go. Right here. This guy. Okay? That one. If I don't know why some of y'all are choosing something different, 1,500 light years away is a long way away from our planet. All right? So this one, and that's the answer. That goes right there. So Deneb and Betelgeuse have the same absolute brightness. That means these are very bright stars. Which one appears dimmer and why? Well, I have no clue. Let's look at Betelgeuse. Here's Betelgeuse. Here's how many light years away he is. See, they're exactly the same on the scale except for here and the apparent brightness. It's because Betelgeuse is closer. Deneb is farther away. He's 1,500 light years away from us. It's a long, I mean, honey, you want to go on a road trip, we'll go. I mean, we're going to be definitely croaked by then, but hey, we tried. So I just need, from here, I need you guys to do me a favor. All right, I'm going to get out my favorite pink writing tool online, and I'm going to say I need one thing here. I'm learning to write with this thing so good. One here, one thing. One thing. Are you guys understanding now? Yeah, one thing. All right, good. One thing. Oh, I kind of cursived. Yay. Let's see, can I cursive? Oh, I can cursive much better on this. Oh, yes. One thing. All right. So this was supposed to be like an extra credit kind of thing that we just didn't have time for. Okay, so we're not going to worry about this extra page unless I send this to you. If I send you this document, that means I need you to do me some extra credit work. And we might do this later. We might not. I don't know. Haven't decided yet. But here's the web link for it. It's all right there. You guys can go click into it and play and study on that for a while. So let's click out of this really quick. Where did my face go? Here I am. So I want you guys to understand the difference. You guys definitely need to understand the difference between white versus red, or blue versus red. Why these blue stars are hotter and why the red stars are cooler. Okay, because I know everybody equates the red being hot because we say red, dangerous, stop, no. Red is hot, blue is cold because you think of ice and you think of things like that, and that's how it works on planet Earth. But out in space, however, if something is that color, or when you're thinking of fire, you do the same thing. So I just want you guys to think that. Yes, I know my hair is crazy today. However, you guys have been awesome as usual, and I will see you in the next episode of our classroom when we're going to go over the sun, and I'm super excited. All right, guys, bye.